now that we have seen the notation for procedures, let's try and write pseudocode for one of the more complicated examples that we did in class, the one where we awarded prizes to the top 3 students in the class. So our goal was to award top 3 prizes, and basically we wanted to give these prizes to the students with the maximum marks, but then we had some side conditions. So one of these was that it's not enough to be in the top 3 overall, you must be in the top 3 in at least one of the 3 subjects. So unless you have done well in at least one subject, and this could happen because we said there could be a lot of variation marks, people who do well in physics may not do well in chemistry and so on. So we didn't want somebody who had done averagely across all the things but somehow got a higher total because the people who did well in one subject did very poorly in the other subjects. The other thing we said is we wanted some kind of equity across gender. So we wanted to ensure that among the top 3 we select, there is at least one boy and at least one girl. We don't want all 3 boys, we don't want all 3 girls. So let's first look at this question about how to find the top 3 in a given category, because that is common to both parts of this. So there are 2 parts if you notice. One is to find the top 3 marks in each given subject, because we need to check that the student is a subject-wise topper, and then we need the top 3 marks overall among the subject-wise toppers. So we will repeatedly need to find the top 3 marks. So let's see how to find this, right? So how do we find the top 3 marks in the category? Well, how to find the top mark in a category we know. Right? This was the very first thing that we did, finding the maximum. So we keep track of a variable which keeps track of the maximum by initializing it to 0, and whenever we see a new value, if it exceeds the current maximum, we update it. So maximum is something we have seen before. What about second maximum? Supposing we want the top 2. Well, if we want the top 2, then we really need to keep track of 2 values, because we need the top value and the second value, and now the update is a little more complicated. So in the maximum case, we updated whenever we saw a new value which was bigger than the current maximum. So only one situation. But now we have maximum and we have second maximum. So we have 2 values, and what could happen is that the new value that we get could come here, which is like updating the maximum, or it could come here, which is that the maximum is not touched, but the second maximum is now replaced by the new value. So there are 2 updates that we have to consider in this case, and we have to do them a little carefully. So if the current value is bigger than the maximum, then we have to first, before we overwrite the maximum, before we copy the value of the current card into the maximum, we have to remember that the maximum now becomes the second maximum. So we first copy the second maximum, the maximum value to the second maximum variable, and only then do we update the maximum. So this is the first kind of update where the new card is bigger than anything we have seen before. And the other situation is when the new card comes in between. In this case, the maximum doesn't change, and we just replace the second maximum as we would have done when we are keeping track of only one value. So with this background, let's try to generalize it to finding the top 3 marks. So as you would imagine, you would keep track of 3 quantities: the maximum, the second maximum, and the third maximum. So let's directly try to write pseudocode for a procedure which finds the top 3 marks in a subject. So this takes the subject as a parameter and is going to compute the maximum, second maximum, and third maximum marks in that subject across all the cards. And this is what we will be using to find subject-wise toppers as part of our 3 prize problem. So the first step is to compute these, is to set up these 3 values and initialize them to 0. And now the usual thing happens, which is we scan through all the cards and we do something. So what is it that we do? Well, we have to update the maximum, the second maximum, and third maximum depending on what the current card value has. So like we saw for the second maximum, there will be multiple cases. Now we have 3 values. We have max, we have second max, and we have third max, right? So now the interesting case is when either the new value is bigger than the maximum, in which case everything changes, or it is in between these 2, in which case these 2 values change, or it is here, in which case only this value changes. So we have to do 3 separate types of updates depending on the current value. Of course, if it is in the last position, if it is smaller than third maximum, then it is of no interest to us, we just move on to the next card, right? So the first situation is when the subject field, so remember the subject is an argument, so it could be maths, it could be chemistry, it could be physics. When the subject that we are looking for is bigger than the maximum, then we have to update all 3, and now the order is important. We have to first, so we have max, second, and third. right? So we have to first make sure that we copy this value there and then copy this value here and then copy the new card value here. Because if we do it in another order, if we first do this for instance, then max, the old value of max is gone. Then we can't copy it to second anymore. So this order is important, right? We have to start with the value that you are willing to discard. In this case, the third max is no longer useful to us, we are willing to discard it. So we overwrite the third max with the second max, then we overwrite the second max with the max, and then we finally replace the max with the current card value, because the current value by assumption is bigger than the max. The second situation is when it falls in the first interval between max and second max. So again we do two updates. We update the third max with the second max, we throw away the third max. We replace the second max with the current value and the overall max doesn't change. And finally, if it is in the third interval, that is between the second max and the third max, then only the third max has to be updated. So these are the three different types of updates that occur because we are looking for the top 3 marks. And the fourth case, when it is smaller than third marks, is where we just ignore the card and move ahead. So at the end of this procedure, this loop rather, what we have is 3 values. We have the max, the second max and the third max. And remember that now this is a procedure, it has to return these values back to us so we can use them. So this is slightly complicated compared to what we had before, because we don't have just one value to return to us, we have 3 values, right? We have 3 numbers, and how do we return 3 numbers and how do we store them? So technically for this we need to have some way of collecting these 3 numbers into a sequence or a list and passing it back. And this will come up later in the course, so we will not look at this now because this requires some new notation and some complications which is best to avoid. So we will see lists later on, but fortunately for the purpose that we are using this procedure, we actually don't need all 3 values. What do we want to check, right? We want to check that the student card that we are looking at is a topper, meaning it's at least as good as the third highest mark. So we really have no interest in the maximum and the second maximum. We want to check whether the student is at least as good as the third maximum. So the third maximum is the only interesting value in this as far as this 3 prize problem is concerned. We have no interest in whether the person is a topper or not in that particular category. We just need to know that they are within the top 3. So fortunately for us, we can replace this list by just a single value, the third max, because once we know the third max, we can discover whether the person is a subject topper without having to go through this other information. So with this procedure, we now know how to compute the top 3 marks and in particular return the third max marks. But since we did it piecemeal, it's a good idea to probably see the procedure as a whole so that you see exactly how the whole thing is laid out. So this is the entire procedure to compute the top 3 marks in a subject. So in the beginning, we did this initialization. We took these 3 values and initialized them to 0. And now this overflows into 2 columns, so think of it as 2 pages. So we have a while loop which goes from here to here, right? So this while loop iterates over all the cards in our deck. So it goes card by card until no cards are left. So we pick up each card and now there are 3 different types of updates which are disjoint, right? Either it is bigger than the max, in which case you update all 3 values, or it is between max and second max, in which case you update 2 values, or it is between second max and third max, in which case you update only 1 value. And in the fourth case, where it's smaller than the third max, you just ignore this card and move ahead. And finally, at the end of this procedure, you return the third max value that you found, because this is what is important for us in order to decide whether somebody is a subject topper or not. So now we come back to the 3 prize problem. So we want to find the top 3 totals such that these totals also include a mark which is in the top 3 in at least one subject. We also have a gender criterion, but the gender criterion is hard to maintain because until we find the overall top 3 marks, we really don't know who's going to be the final 3. So we can't really keep track of the boys and the girls in this list until we compute the top 3. So we will postpone this issue about boys and girls till the end when we compute the top 3, and if it is not correct, we will figure out how to fix it. So right now what we want to do is find the top 3 totals which are also subject toppers. So once again we will maintain an update, max, second max and third max, and scan through all the cards, and for each card we will update this max, second max and third max, provided that particular card is a subject topper. If it is not a subject topper, even if it has a total which is high, we will ignore it. So in order to compute this subject topper criterion, we need to first find out the subject toppers and save them. because we don't want each time to go through and find the top 3 marks in each subject for each card that we look at. So what we will assume is that we will call our previous procedure which finds the top 3 marks, we will call it once for maths, one for physics, one for chemistry, and we will store the third highest mark in each of these subjects. Then when we look at a new card, we can compare it against this third highest marks and quickly decide whether or not this particular card qualifies to be a prize winner. And if it qualifies to be a prize winner, then we will check whether we want to update max, second max and third max for the total marks. So if we do this, which we will see in detail, at the end we will have the 3 prize winning totals, just like as before we had the 3 highest marks in each subject. But the situation here is different. It's not really enough for us to have the 3 prize winning totals, because we need to know who the winners are. Right? Finally, it's not good enough to know that the top mark was 281 on 300. We need to know who had 281 on 300. So just like we saw when we did the maximum right at the beginning, there is a problem of finding the maximum marks in a subject, but there's also a related problem of identifying who it is. So we need to keep track of the ID of the card which contributed this maximum. So we need to keep track of the card number of the prize winners along with the marks of the prize winners as we go along. So that is another difference between the 3 prize version of finding the top 3 and finding the top 3 in a given subject. So let's look at the pseudocode now. This is not going to be a separate procedure. This is our main code, so we will just write it as a sequence of steps where we'll of course use the procedures that we had. So the first thing is to set up our 3 variables for the marks, max, second max and third max. But we also have 3 variables for the IDs, max ID, second max ID, third max ID, because we need to keep track of which cards contributed these values. And the IDs we are assigning to -1 to make sure that they are not any of the card IDs which are already in the deck. So we are pretty sure that the cards don't have negative numbers on them as their IDs. So we assign them to -1, so we are not confused whether this is a valid ID or not. If we see a -1, we know that there is no card which has seen so far. So that is our first step. We have initialized these 6 variables. Now what we said was that we don't want to recompute this third highest marks in each subject again and again. So we do it once and for all in the beginning, and we remember these values in 3 variables. So we have 3 variables, maths 3, physics 3, chemistry 3, each of which records the third highest marks in the appropriate subject by calling our previous procedure top 3 marks with the appropriate subject name. So this is part of our setup. So the first setup was just initializing the variables we will be using to keep track of the top 3 prize winning totals. And then the second setup is to keep track of the marks that we need in order to decide whether a given card qualifies or not under the subject topper criteria. So now we have our familiar loop where we pass through all the cards and we do something, and that something is to update the max, second max and third max for the totals. But remember that we do this only if the card qualifies as a subject topper. So we have to check whether the marks on this card for each of these 3 subjects, whether at least one of them is above the third highest. And since we don't want this to be computed again and again, we assume that we will use the values we have already stored in these maths 3, physics 3 and chem 3 variables. So for the moment, to make it simpler, we will assume that we have a procedure which we will call with the current card and with these 3 thresholds, these 3 third highest marks, and it will return back to us either a true saying yes, this card is a subject topper, or false saying no, this card is not a subject topper. If it is not a subject topper, we have nothing to do. We can just ignore it and go ahead even if it has a high total. If it is a subject topper, now we have to do this multi-way update depending on the total marks of this card. So the first case as before is when the total is bigger than the overall maximum. Then we have to do this 3-step thing. We first replace the third maximum values, then we replace the second maximum values, and then we replace the maximum values. But now the difference is that we also have to do this for the IDs, right? So earlier we were only dealing with the totals, now we are also replacing the IDs. So it's a slightly more involved update. Each time we have to update the marks and the ID in each category. The second situation is when it lies between the first and the second max, in which case we update only 2 quantities, the third max and the second max. And the final situation is when it lies below the second max but above the third max, in which case we just replace the third max. So now if we go through this, at the end of this we have these 6 variables that we kept track of. for each variable we had the marks, we had the max marks and the max ID, we had the second max marks and the second max ID, third max marks and the third max ID. Now actually notice that if we have the IDs, we can always go back to the card and get the marks. So we don't really, technically speaking, need the marks because we can go back, but then we have to go back, right? So we have to go and look up the card again in order to get the marks belonging to that ID. So though it's enough to keep track of the IDs, it's useful to keep track of the max marks and the ID for each of these categories. So we want to finish off this code, but we have this hanging subject topper. So let's see what subject topper looks like. So subject topper requires us to compare each subject's marks with the third highest. So we have a card, right, and then we have these three values. So what we want to check is whether the maths marks on the card is bigger than the third highest maths mark, or the third highest physics mark for the physics value, or the third highest chemistry mark for the chemistry value. Now notice that this particular procedure, subject topper, doesn't really know that these are the third highest marks. So for instance, tomorrow you could also use it if you wanted the fifth highest marks. All you have to do is pass the right parameters. All that the subject topper procedure is doing is checking that the maths marks are above the maths threshold, the physics marks are above the physics threshold, and the chemistry marks is above the chemistry threshold. What that threshold is, this procedure doesn't care. It's just telling you that at least one of these is above the given threshold in that subject. So since we want this at least, right, we need to compare these, and this is done using this OR operator. So this OR operator basically tells us that one of these conditions should hold, more than one could hold, but at least one should hold. So either it should be that the maths marks is above the threshold, or the physics marks, or the chemistry marks. Now what does this function return? As we said, if the threshold is true for at least one subject, it will return true, otherwise it will return false. So when we go back to the function or the procedure that called this, technically what it would have to do is it would have to call this procedure and check the value against true or false. So we would have to say, is subject topper of a given card X with respect to the maths, chemistry and physics marks, is it true? But the outcome of this is again going to be true or false, right? So when is it going to be true? It's going to be true when the outcome of the subject is true. When is it going to be false? When the outcome of subject topper is false. So if subject topper returns false, this equality check will return false. If subject topper returns true, then this equality check will return true. So we actually don't need the equality check. We can just take directly the value that subject topper gives us. If it is false, this test is false. If it is true, the test is true, and use that as our condition. That's what we wrote in our code. So we can eliminate this equal to true, because it's only the value returned by this function which is important to this procedure. Right? This procedure tells us true or false. If it is true, we do something. If it is false, we don't do something. So this is a small simplification of the pseudocode. It also makes it easier to read. So now we have the subject topper pseudocode. So we are now ready to write out the pseudocode for the 3 prize problem in more detail. Right? So here is the full 3 prize problem. So we have these 2 initializations, the max values and the max IDs. Then we have this 3 calls to the top 3 marks procedure that we had before to set up the 3 thresholds. And then we have our familiar loop, right? So we go through all the cards up to here. And for each card, we first check whether or not it is a subject topper. If it is not a subject topper, and this ends here, if it's not a subject topper, we just skip the card. We do nothing. We don't look at the total at all. If it is a subject topper, then we scan the total in 3 ways as before. We check whether the total is bigger than the max, or we check whether the total is between max and second max, or we check whether the total is between second max and third max. And at the end of this, we have these 3 values, max, second max, third max, and the corresponding IDs, max ID, second max ID and third max ID. So now let's come up to this question about gender. So we have computed these top 3 marks. What if they are not of different genders? Well, we have to decide what we want to do, but the best solution obviously is to knock off the smallest of these 3, right? To take off the third. So supposing they are all 3 boys, then we take off the third boy, because we know that the top girl is below the third boy. So the top girl is at most 4th overall. So then we go through and we look again, having eliminated the third highest boy, in the hope that now this third highest boy will be replaced by a girl. So how many times we do it? Well, we have to keep doing it until we find a card with a different gender popping up in the top 3. So this is something which we have to check now. Will we always will this always give us 3 valid prize winners, right? Now, of course, if all the girls or among the girls there is somebody who is a subject topper, you can check that you will get it. But what if none of the girls is a subject topper? If none of the girls is a subject topper, then you will never find a girl who qualifies for a prize, because that is the first criterion, that unless you are a subject topper, your total is not even counted. So there would be a situation in which we keep doing this and finally we find that there is no way to award a prize. So we have to then go back and revisit maybe how we have chosen these prize criteria. So these are some issues that come up when you formulate a problem. You initially come up with some criteria and then you later on realize that these criteria need not be sound. The other thing that we have to look at is ties. See, what if there are 2 students who have the same number of marks? So if there are ties for the top place, for instance, if there are 3 people who are tied for the top place, they will get the first 3 prizes. What if there are 4 people? We have a problem. Similarly, if there are 2 people tied for the second place, it's okay. We'll give 1 person for the first place and the second and third will get the 2 people tied for second place will get 2 prizes. But what if there are 3? So therefore, the number of ties we can tolerate in this procedure also depends on whether the ties happen at the first position, the second position or the third position. So once again, if we have a lot of ties, then this procedure will result in some arbitrary choice about who gets the prize and who doesn't get the prize. So to summarize, this lecture was an illustration of a reasonably complicated problem worked out in detail in pseudocode. One of the steps that you must take away from this is that it is very useful to break up your pseudocode or your procedure into natural units, right? So you want to take the main procedure and block it off into repeated things, like we found here the top 3 marks again and again, or we found the subject topper by not having to call it again and again. So make these into separate procedures so it makes it easier to modularize and read your code. We also saw the shortcut for looking at values returned by procedures which give back Boolean values. And finally, we saw that in the situation of gender or with ties, we have to sometimes look back and see whether the problem that we have solved has been solved correctly and in some sense whether the solution can work in all cases or not.